Hi there, I'm Kevin Benedict, Principal Analyst for the Center for Digital Intelligence, and I want to thank all of you guys for joining us today. I'm thrilled here at the Center for Digital Intelligence to have one of my good friends and just a very talented and smart individual. It's Sam Lakkundi. He is in charge of global SAP channels, big data, IoT innovation, all these fun things at OSI Soft. Sam, thanks for joining us from Orlando, Florida.
Thank you, Kevin. Good to see you again, my friend, and good to see you in lovely Idaho. So
yes,
one day
I had the opportunity to be out on my deck today, so that's a privilege until the neighbors start throwing things at me.
Yeah, exactly.
So Sam, talk to us about the Internet of Things. I mean, you've come out of mobility, you've been in the Internet of Things, you've been in all kinds of different really interesting emerging technologies. Talk to us about the Internet of Things and platforms.
Awesome.
What do you see out there, and what do you guys have?
Yeah, so let me provide context of what the Internet of Things for me is specifically more, and then I'll talk about the platform and so on. So, the way I look at the Internet of Things is we started originally with the Internet of People, right? I mean, many years, back when, we got the Internet, when, we were dialing it into broadband modems and hearing the familiar, you got mail sort of, when the Internet started. That was the Internet of People, where people connected to other people and got super excited, right? So when you heard that you got mail and that was our first, or you heard the familiar beep, beep, beep noise on the modem, you got excited that you were connecting into the possibilities of endless, immense knowledge when Netscape had just evolved and the internet war was on. So browser war was on in some sense. And so that was the Internet of People. So where people connected to people, and that's really what started the whole revolution of, my God, it's just as easy as connecting to Kevin right now sitting in Idaho on his back deck than it is for me to connect to my own friend sitting on a back deck, 2 doors away, right? So, and that's, was the first big revolution.
Mm-hmm.
Today, when people talk about Internet of Things, I think it is the second big revolution in not people connecting to people, which is really now, a given, right? I mean, so it's the, things actually connecting to other things is really where the evolution is now, which is, everything around me as I sit in my office here, or if, as I sit around, look around me, whether it's my Nest thermostat or it's, as simple as my ceiling fan, which I can now control over an internet. My definition of the Internet of Things, evolving from how we actually came up with, Internet of People per se,
yes.
Right? And
yes. So I see, we started out Internet of People in a stationary kind of desktop environment. Then we went Internet to people wherever their phones were in wireless environments. And now we're here, Internet of Things, and those embedded sensors can be on anything.
Correct. And that's where the beauty is, right? So like you said, articulated, beautifully, we started off with hard-coded desktops, and that was how we were connected to other people. And then we were let free with the advent of the phone, mobile phones coming in, and then not only being able to talk and text, but also being able to actually connect live to somebody, right? Where we are today, it's almost a given where we physically do FaceTime to talk to each other and have the internet in that sense. So yeah, absolutely.
So then companies had these mobile platforms which allowed them to securely connect with all their employees.
Correct.
And
Yes.
then there's the consumer side where they could transact and commercially interact with their customers. So you had those two kind of components of the wireless environment. Talk to us now how those platforms evolve to then support the Internet of Things.
So, from evolving from, supporting, systems and supporting, if you take a look, right, if you're in the 6th generation of technology, right, starting from sort of the mainframe going into, internet browsers and internet app servers, and then going into mobile and so on, and where we are today. In reality, not much has changed, right? In this sense, mainframes are called today as enterprise servers, right? And mobile is still mobile, right? They're called as mobile platforms, and they've evolved, and it's a secondary nature. So the Internet of Things basically allows people now to take those existing systems and then evolve them into things that actually matter, into where, for example, asset management, right? So a lot of people, IBM with its cognitive computing seems to be ahead of the game with Watson and so on. The reason is they got a huge leg up because they have those enterprise servers. They have that data from 30 years ago. They know exactly, what transaction people did at a gas station, right? So that's, my assumption on how it's evolved.
Okay, so in the world of industrial Internet of Things, you're not just collecting data from sensors, but you're collecting that data, you're reviewing it, analyzing it, and then taking action and doing stuff and commanding things to do things. So the machinery needs maintained and needs shut down now because of the data coming in from the sensors. Let's shut down the system. And that can also be done remotely through these kind of platforms. Walk us through that.
Yeah, so, I joined a company called as OSI Soft where I am today. And one of the reasons I think it's a super, important company, specifically in the age of IoT, they have been doing IoT since its inception, since IoT, sort of came into inception, in the sense that they have been collecting data from sensors. And when I mean sensors, it could be things such as turbine engines, things such as oil wells, and a caterpillar moving in a mine. So they, all of this actually has data coming from it, right? And so that data from a mining company or from an oil company has been collected for the last, I don't know, 50 years or so, right? This is nothing new to these companies. If I go and talk about IoT to ExxonMobil, for example, they'll say, we've been collecting this for forever, right? So this is, IoT is not new to us. The way you actually assimilate that data and how you look at the data and utilize the data has been the advancement in what we do today, right?
Talk to us about that. What you're sharing, it seems like, is that there's now being layers of analytics,
yes,
both big data and analytics, on top of that information flow.
Correct. So, in some sense, if you take a look at organizations, right, and they're deploying this data, and they're being, held accountable for this large amounts of data that they've had for like 22 years. So, for example, how do I actually take this data from these sensors and how do I make sense of it, right? You talked about a concept of like, I would know how an equipment fails or when it would fail. So maybe 20 years later, I probably didn't have the accurate data to figure out. I knew that there was a failure that probably would happen, but I could not predict exactly when it would happen. So today I have that information. When I apply algorithms for artificial intelligence, which actually relies 100% on data or machine learning, which now gets into the concept of predictive analytics or predictive maintenance, which gives me the ability to now take a look at this data and specifically tell me when that particular equipment is bound to fail. And how does it get this data? How it gets this data is not only from one oil well pump, but it gets it from the thousands of oil well pumps that an oil company might have, based on the life that they have, based on the heat index, based on the vibration, based on the condition of how much oil is being generated. I can predict almost to a very accurate, time on when that equipment will fail based on all these factors on the other pumps that are out there, right? Not only on the pump that we have.
Very good. So just thinking that through, you're going to have data that's accumulated over decades that you can then look for patterns and apply that to inbound data now. So you can say, this looks like patterns we've seen in the past. Here's some recommended actions. So, but you must also have kind of actionable data that requires real-time responses.
Yes.
So how does an Internet of Things platform channel kind of real-time data with batch data that's not time sensitive with really time sensitive data? How is that actually divided and handled differently?
Correct. So this is an important concept of real time, which is basically what we call as hot data versus cold data, right? Cold data is okay because I can collect that data, I can do decision tree, analysis, I apply different machine learning algorithms on it because it's cold data and I have massive amounts of data to look at. Whereas real data, right, today mostly is connected to a human machine interface, right, where a person is physically sitting and looking at the behavior of what that machine is doing and so on. So when real-time data comes into it now, because of the advancement of computing power, of basically cloud-based systems, I can then take these patterns and as the data moves in, start doing analysis on it and figuring out, what, the heat index and vibration of this machine seems to be about 35 psi, which is the norm is 20, and the data coming in is 30. There's some problem that's coming in. We should probably stop it. And so this is basically the live data coming in and doing live analysis versus doing predictive maintenance, which is based on cold storage or cold data, right? That is out there. Right.
So when you're sitting around a table with your strategy team and you're saying, okay, we have all these new sensors in place here. We're going to put these sensors in different categories. This data is going to be nice, but it doesn't need to, it's cool data. It doesn't need to respond to immediately. This is hot data over here. We need to know if anything changes on this data. So then what do you route the data from the hot sensors, if you would, to a different channel and then apply some faster analytics and reporting on that? Is that how that works?
It's a combination of things, right? So what we have been able to do is basically channel in data. So what we call as is hot data, which is live and streaming in. Warm data, which is basically I'm mixing in some cold data and then warm data and getting some real based analytics on that. And then cold data, which is really my massive amounts of years of data that I'm accumulating. So the platforms today, whether it be the SAP HANA platform that allows us to do this, or some other platforms, right, that allow us to do this, or Microsoft Azure or what have you, right? They give us the ability to actually intermingle this data to come up with different scenarios and different sort of analytics to showcase what's the best predictive or the best sort of analysis that can happen, whether it's live, whether it's stored, or whether it's intermediary, right, which is in transit to become cold, or in transit basically, which is in a sense of basically discarding it because, hey, the machine is normally running, I don't care for it, I'm just going to discard it at this point.
Right. So you have hot data, it's coming from machines that are very critical to your business and your manufacturing operations, if you would. You also need to shut it down. Now imagine if you're giving kind of the ability for machine-to-machine communications, you're analyzing the data, something's wrong, and you send back instructions to the machine. That makes that vulnerable to hacking and to bad guys. How do you secure that so that somebody else isn't taking control of machines in your plant?
Correct. So, in some sense, welcome to the era of Internet of Things. where digitally connected devices are basically encroaching every aspect of our life, right? So securing the Internet of Things is a tricky business, right? Kevin. So take the fact that these IoT devices come in every shape, size, and function. This makes traditional endpoint security, models impractical, right? On top of this very nature, IoT devices are resource constrained in terms of power, performance, functionality, and so on and so on. So, as IoT security challenges continue to grow, so does, the need for technologies that process to address the problems, right?
Mm-hmm.
In my sense, how do you prevent this security aspect? How do you basically take care of the security aspect? One is, of course, the good old network security that they have been used to. IoT networks are predominantly wireless, right? And so now, as wireless overtook wired global internet traffic back in 2015, this makes security far more challenging with traditional wired, networks due to the variety of emerging RF and wireless communications and standards that are there. Then authentication, right? So if you take a look at authentication, IoT devices must be authenticated by all legitimate users, right? Basically, you have unique to IoTs the devices which are like embedded sensors, which will need basically things to authenticate other devices. You need to implement encryption, right? Which will be needed to prevent unauthorized access to data on these devices, right? And encryption, right, Kevin, must be the part of this complete security management process that you're encountering. And then you have the security side, channel attacks or security analytics and threat prevention, interface protection. So how do you take care of it? I mean, in summary, if you take a look of what your question you asked is the rapid growth of these IoT devices and these challenges posed by wireless connectivity among these devices, necessitates, basically an expanded focus on cybersecurity, right? And these key technologies, whether it be how you deliver it, how do you do, sort of IoT device management, becomes sort of a key norm in how you actually do internet security or IoT security.
So does OSI Soft, do you guys have it? Or is that a layer that you would buy from some enterprise security vendor?
So it's a combination, right? So because naturally our focus at our OSI is basically taking data from these sensors and putting them into what we call as a historian, and then doing advanced analytics on it, right?
Yes.
But once so we basically work with the best of breed of security providers who are, that's what they do every day. They get up and breathe and sleep, into security. But that doesn't mean that we don't handle it, right? So naturally, we as a vendor pulling in this data from these sensors, these are, this is very, very important. I mean, think about data that you're pulling in from a nuclear plant, right? And we have a lot of those.
Yeah. Well, we can think of simpler examples, just, our own home automation, our own door locks.
Yes.
Right? Starting our own vehicles. We don't want people unlocking our house, turning up our heat, stealing our car, et cetera, et cetera. So I just, we have to think through all these things here. So in your world, do people talk about blockchain as a component of some of these things?
Not yet, right? So because, blockchain in our world has been very focused on mostly, in the financial markets and how you actually, authenticate and so on. But I see that trend and sort of that, focus coming into our part of the world as well, where basically you use that, that blocks of security, right? Where everything is not stored in one place, and that's what blockchain is about. You authenticate from parts and bits, and so that becomes an entire block. So I see that trend coming to our world as well. But in my experience, we have not, been there or gone there as yet. So
got it. So artificial intelligence, of course, is something we're all talking about. Probably, well, it actually is justified, in our discussions. So talk to us about the role of artificial intelligence in these data streams that you're getting through these Internet of Things platforms.
And artificial intelligence, in my perspective, has got, I feel that gotten quite a bad reputation, right? Courtesy of science fiction novels and movies and stuff. When you think about AI, most people's minds go to 2001: A Space Odyssey or the Terminator series. While a true sentiment AI might create a threat if not properly, sort of regulated, machine learning algorithms are the foundation, basically, of artificial intelligence, right? So a lot of people, when I worked at a previous company and talked about artificial intelligence, people always got this fear, oh my God, does that mean we are going to be overruled by machines and my job is going to go to a machine one day? And, and IoT and AI have a very sort of, closed loop on that. My perspective is, if you take a look at, AI is based on deep learning algorithms, right? Deep learning involves an automatic feature detection from data. AI techniques can be applied to a range of these data types, including images and sounds and transaction data sequences and natural language processing. But in my realm, as IoT scales to millions and millions of devices generating overwhelming amounts of information, I believe that AI offers the best chance of quickly and accurately making sense of all this big data and putting it to work for us for solving real world problems, right? So that's, my sort of presumption of how artificial intelligence.
Yeah, that is fascinating because, one of the things that I've been writing a lot about is that technology has moved beyond the speed in which humans can facilitate transactions. So when data's coming in, it will overwhelm us. We cannot be the bottleneck in the data and data decisions. And that automatically means we have to find a different way, a digital way, and that's going to be artificial intelligence and automation, robotic process automation, everything that can look at the data, follow a decision tree based on the result of the data, and then take action on that in milliseconds, which of course is an inhumane speed.
Exactly. I mean, simple things, right? I mean, think about, I have a Nest thermostat in my house, and the Nest thermostat is all constantly learning from me, right? And it's learning when I'm home, what temperatures do I like, what temperature do I like at night, and think about, so that's all IoT, right? I mean, it's basically the IoT. And when IoT and AI come together, is the beauty of if I'm driving from, let's imagine that I'm in Jacksonville and I'm driving and it's 2 o'clock in the afternoon and it's already like 95 degrees at home because I didn't turn it off because it says, well, Sam is not at home till 5 p.m. But, fortunately, I'm driving home early. It's 3 p.m. I'm going to be there at 3 p.m. I don't want the thermostat to turn on at 5 p.m. The Nest thermostat says, where is Sam? He's only about 20 minutes. Looks like he's driving home because a route basically is showing home. Would I, shouldn't I be able to actually turn it down to like 72 degrees, which is his desired temperature, before he comes home at 3:30 so that it's nice and cold for him, rather than wait till he comes home and manually turns it on? That data, that is basically, IoT and artificial intelligence coming together, right, in that form.
And that's brilliant. You and I have both been in technology for a long time, Sam, and we know none of that's easy.
Yes.
And we know that takes time. So I think there's going to be, even though we see a lot of advances happening very rapidly, there's still just a lot of hard work and plotting to make these algorithms, to build off them, to learn off them, and to make things even more powerful. But with that, Sam, I want to thank you for taking your Friday afternoon on, Labor Day weekend, and giving us your expertise. So thank you very much for joining us, Sam.
Thank you, Kevin. Thank you for your time. Have a great weekend.